Your teacher at the course, and in this video we'll be looking at hydrogen and the compounds of hydrogen. Hydrogen was first discovered by Henry Cavendish in 1766. Then he put iron inside H2SO4 and discovered that a gas, colorless and odorless gas, was produced. The gas was later named by Antoine Lavoisier as hydrogen. Hydrogen means water former. That's the meaning of hydrogen. Occurrence of hydrogen. Hydrogen does not occur freely in nature because it is very reactive. However, it exists in a combined state in water as H2O, in protein as amino acid polymer, in carbohydrates. Hydrogen position in the periodic table is more than one. So you see that in the periodic table, most manufacturers just put hydrogen on top and allow it to float. However, it can be placed in two groups in the periodic table. It can be placed in group 1 because it has one valence electron like every other element in that group 1. And also it can be placed in group 7 because just like every other element in group 7, it needs only one electron to attain stability. So you can see the rogue nature of hydrogen can be placed in both group 1 and group 7 because it has similarities to both groups. For example, like group 1 element, hydrogen can form a unipositive ion, that is an H plus ion. That's unipositive ion because it just needs only one more electron because it has only one electron in the valence shell. It can also form a uninegative ion like the elements in group 7 because it already has one electron, so putting one more there will make it become 2, and with those 2 it can attain stability. That's a uninegative ion. Hydrogen exhibits isotopy. And what do we mean by isotopy? Isotopy is the existence of atoms of the same element. Take note of that. Atoms of the same element having the same atomic number but different mass number. So these atoms of the same element that have the same atomic number but different mass numbers are known as isotopes. So learn to distinguish between isotopy and isotopes. Isotope is so the isotopes are atoms of the same element, whereas isotopy is the existence of atoms of the same element. Isotopes usually have the same chemical properties but different physical properties, due to the fact that isotopes will have the same number of valence electron, then they are going to react chemically the same way. However, they have different mass numbers, hence they are going to be having different physical properties because mass is a physical property. So if they have different mass number, then they have different physical properties. We have 3 isotopes of hydrogen. Number 1 is protium, which is hydrogen 1,1 or simply H. We have deuterium, hydrogen 2,1 or simply D. And we have tritium, hydrogen 3,1 or simply T. Out of all the three isotopes, protium is the most common isotope of hydrogen. It has a percentage abundance of about more than 99%. Whereas deuterium, usually known as heavy hydrogen, is next in abundance. While protium has 1 proton, 0 neutron, deuterium has 1 proton, 1 neutron. Tritium is radioactive in nature. It has 1 proton, 2 neutron. That's why the mass number of protium, which is hydrogen 1 is only 1, whereas the mass number of deuterium is 2, because one of them is proton, the other is neutron. Then tritium has mass number of 3, because there's 1 proton and 2 neutron, making 3. So take note of that. Other elements that exhibit isotopy are chlorine, carbon. Carbon has diamond and graphite as carbon rather has carbon 12, carbon 13, and carbon 14 as isotope. Carbon 14 is a radioactive isotope. It's used for carbon dating. Iodine also has isotopy. Phosphorus has isotopy. Uranium also have isotopy. So this will be the first video telling us about hydrogen and the isotopes of hydrogen.